This is Dr.S. Selvalakshmi, Assistant Professor of Physics, the Standard 5X Rajaratnam College for Women, Sivakasi. In this video, we are going to see about the molten carbonate fuel cell. On seeing this video, you will be able to know the history of molten carbonate fuel cell, describe the working principle of molten carbonate fuel cell, analyze the advantages and limitations of MCFC, and identify the applications of molten carbonate fuel cell. Let us now move on to the history of MCFC. In the late 1960s, Dutch scientists G.H. Brouwers and J.A.A. Ketelaar reported the first MCFC prototype. Later, the US Army's Mobility Equipment Research and Development Cell tested several MCFCs made by Texas Instruments ranging from 100 to 1000 watts. The molten carbonate fuel cells are used in large stationary power generation. Molten carbonate fuel cell is a high temperature fuel cell that uses a molten carbonate salt mixture as an electrolyte. It is used to produce electricity from fuels like natural gas, coal and biogas. Due to high operating temperature, these fuels are converted to hydrogen within the fuel cell by a process called internal reforming, which reduces the cost. The molten carbonate fuel cell comprises of an electrolyte, a negative electrode, positive electrode, catalyst, fuel gas and oxidant. The electrolyte used in this molten carbonate fuel cells are potassium carbonate or sodium carbonate or any other carbonate. The negative electrode is the porous nickel based alloy, and the positive electrode uses lithium metatitanate or lithiated nickel oxides. The catalyst used here is the nickel. And the fuel supplied to this MCFC is hydrogen and carbon monoxide, and the oxidants used are oxygen and carbon dioxide. Let us now see the working principle of the molten carbonate fuel cell. At the anode, the hydrogen supplied as fuel reacts with the carbonate ions of the electrolyte to produce water, carbon dioxide and electrons. The electrons travel through the load generating electricity. At the cathode, the carbon dioxide from the anode and the oxygen supplied as oxidant react with the electrons to form carbonate. These are the reactions that are taking place at the anode and cathode, and finally the electrons which are formed at the anode goes through the load and generates electricity. The following table represents the characteristics and performance of MCFC. The molten carbonate fuel cells operate at a temperature between 600 degrees Celsius to 700 degrees Celsius, and the operating pressure ranges from 1 to 8 atmospheric pressure. The electrical efficiency of MCFC is about 60 to 70%, and the power production from MCFC is 0.3 to 3 megawatts. The advantages of MCFC are it is a high efficiency power generating device, and here we do not use any expensive catalysts like titanium or platinum etc., but we use very cheap nickel as catalyst here. And these MCFC produce immediate electricity by a fast reaction kinetics. And here the internal reforming reduces the cost, since the conversion of hydrogen takes place within the fuel cell itself. And the main disadvantages of MCFC are using of liquid electrolyte rather than a solid electrolyte. So, the solid electrolyte does not produce any corrosion, but the liquid electrolyte produces corrosion and reduces the durability of MCFC. And here we need to inject carbon dioxide at the cathode to produce carbonate ions. And here the high temperature, operating temperature produces corrosion of the electrodes. Thus, the electrolyte being molten state produces corrosive nature, and the electrodes start to corrode easily. So, these are the disadvantages of molten carbonate fuel cells. And now the applications. MCFC are used in power plants for electrical utility in industries and the military purposes, and MCFCs are used as alternative power supply for ships and can capture carbon dioxide for flue gas. Thank you for watching this video. Let us learn something new in the next video. Thank you.